Hello students, two particles of mass, one is small letter m, next one is capital letter M, are initially at rest at infinite distance. They are at an infinite distance. At any instant, when the separation is d, means they are approaching towards to with each other at some particular distance d. Square of their relative velocity of approach due to mutual gravitational attraction. You know, mutual gravitational attraction means what? Velocity of center of mass is zero. Let us move the actual concept. Here, first one, there are the two masses. Two masses I'm choosing. These two masses, they are coming from infinite distance. This is from infinite distance to here they are moving. Let it be its mass is m. This is capital letter M. And they are moving with velocities, means approaching. They are approaching with velocities v1 and v2. The distance of separation at any instant is d. D is the distance of separation. Now we can move. The concept is that first when they are moving on a straight line path, according to the conservation of linear momentum. Conservation of linear momentum. Conservation of linear momentum. What is that? So, from the velocity of center of mass, VCM is equals to m1 v1 plus m2 v2 by m1 plus m2. Velocity of center of mass, VCM is equals to, they are approaching small m v1 minus capital M v2 by m1 plus m2. This is 0 is equals to m1 v1 minus mv2 is by, so this is what m1 plus means m plus capital M. So finally m into v1 is equals to capital M into v2 is the required relation. Okay, let it be, I'm subjecting v1. v1 is equals to m by m into v2. Okay, so let us move now. When they came to this position, which one here is this spot, means when very first one is this. Here, this is the one position, next position. Distance of separation is, it's a d. So we can apply conservation of mechanical energy. So from the conservation of mechanical energy, conservation of mechanical energy. So what is the conservation of mechanical energy? Mechanical energy. Sir, total energy at infinite distance is equals to total energy at a distance d. What is the total energy at infinite distance? Is a 0. Is equals to kinetic energy initial or final. Final actually this potential energy final. Potential energy means interaction energy. So now kinetic energy, this 0 is equals to kinetic energy of first one. Okay, this initially for small m and capital M. Half m v1 square plus half capital M v2 square minus g capital M small m by d. So now I'm going for the simplification. Half m v1 square plus half capital M v2 square is equals to g mm by, it's a d. Now we can write, so for this relation I'm choosing, so what is v1? This is half m, v1 is capital M square by small m square into v2 square plus half capital M into V2 square is equals to Gm M by D. So this one M and M cancel. It's a half M square by M into V2 square plus half capital M V2 square is equals to G M by D. So now I want to check on this. First one, here one M, this M cancels. Now I'm continuing with this. Here I can write it as half M, okay, by M into V2 square plus half V2 square is equals to Gm by D. Now, half V2 square is common. This is capital M by small m plus 1 is equals to Gm by D. So this V2 square is equals to, or V2 square times of M plus M by M is equals to 2 Gm by D. So this V2 is equals to under root of, okay, square root of, now this become as 2 Gm square by 2Gm square by D times of capital M plus small m. This is V2. So V2 I know this. Now I want to go for V1. Finally, V2 is equals to M times of under root 2G by D times of M plus M is the required relation for V2. So V2 I got it as this. V2 is equals to M times 2G by D times capital M plus small m. Okay. So V1 is equals to what? What is the V1? So V1 is equals to, V1 means we have a relation from this. What is this? V1 is equals to, V1 is equal to M by M times, okay, V2. Chalo, what do you say now? V1 is equals to M by M times V2 means small m square root of 2G by D times M plus M. Cancelled. V1 is equals to M under root of 2G by D times of M plus M. So this is V1. Now this is V2. So what do you want now? When two particles are moving, approaching towards with each other, its velocity V1 and V2. Velocity of one with respect to another, V relative is equals to V1 plus V2 if they are approaching. If they are moving in the same direction, V1 minus V2. So this can be written, this is V relative is equals to, V1 is M plus M, okay, V1 plus V2, and just I'm directly substituting 2G by D times of capital letter M plus small m. Okay, so this can be written, is square is asking V relative square is equals to, what is the condition? So capital M plus small m whole square and root cancel. So one term will be cancelled. Then I can say 2G times M plus M by D is the required relation. You may ask us any relation like